All right, so welcome back, students. If you follow the previous lesson, you realize we are studying matrices. Now we looked at the introduction to matrix, we looked at the types of matrix, and then we looked at addition and subtraction of matrix. Now on this episode, our main focus is to look at multiplication of a matrix by a scalar, and then look at how to multiply 2 by 2 matrices. Okay, that's our main focus here. And then if there is more time, we'll look at how to find the determinant of 2 by 2 matrix and then determinant of 3 by 3 matrix as well. So let's go on. Now, if I have a value m, right, and a particular number is multiplying m, that number multiplying m is actually called a scalar, okay? So you realize that, for instance, so here I have m. Here, if I have a matrix m and it's A, B, C, D, then if I tell you to find 2m, which means that the coordinate of m is multiplying what? 2 is multiplying the coordinate of m. So since the coordinate of m is A, B, C, D, then it means that my new matrix becomes 2a, 2b, 2c, and then what? 2d. Are you okay? So a typical example is here. Now if m equals 2, 3, 4, 5, and n equals 3, 4, minus 3, minus 4, then if I want to evaluate 3m, then 3m is going to be 3 times the coordinate of m, and the coordinate of m is 2, 3, 4, and then 5. So the final answer is going to be, now 3 times 2 is going to give me 6, then 3 times 4 is going to give me 12, 3 times 3 is going to give me 9, and then 3 times 5 is going to give me what? 15. Okay, so this is going to be the answer for 3m. Now the second one says we should find the value of 2m minus 3 what? n. Now if I simplify this one means 2 times the coordinate of m, which is 2, 3, 4, 5, and then 3n means 3 times the coordinate of n, that is 3, 4, minus 3, and then minus 4. Okay, now simplifying this, I have 2 times 2 is going to give me 4, 2 times 3 is going to give me 6, 2 times 4 is going to give me 8, and 2 times 5 is going to give me 10. So simplify this for minus. Let me simplify this. Now once I have brought the minus here, you should multiply this one with a 3, not negative 3, because I brought this negative sign here, right? So 3 times 3 is going to give me 9, 3 times 4 is going to give me 12. Now 3 times negative 3 is going to give me negative 9. Now 3 times negative 12 is going to give me negative 4 is going to give me negative 12. So at the end, I subtract these two values. So now you realize that if we are subtracting first minus first, right? So 4 minus 9 is going to give me what? Minus 5. Now 6 minus 12 is going to give me minus 6, right? Now 8 minus 9. Remember, minus will give me what? Positive, right? So here 8 minus 9 is the same as 8 plus 9. Again is what? 4, right? A teacher of mine will say again is forget, right? So 8 plus 9, that's going to give me 17, I guess, and then 10 minus 12 is going to be 10 plus 12. That's going to give me 22, right? So 2m minus 3n is going to give me minus 5, minus 6, 17, and what? 22, right? Now let's look at the third solution, which we have 3 bracket of 4n minus 3m. So if you have something like this, how do you go about it? So we still apply board maths. We solve the ones in the bracket first, right? This one is the same as 3 big bracket because I'm going to introduce another bracket inside. This one is the same as 4 times the coordinate of n. And remember, the coordinate of n is what? 2, 3, 4, and then what? 5. Minus 3 times the coordinate of m. And then the coordinate of m is, the coordinate of n, I think, is 3 from the board, is 3, 4, minus 3, and then minus 4. And then the coordinate of m rather is 2, 3, 4, and then what? 5. So let's simplify what's inside the bracket first, then after we multiply with the number out. Okay, now multiplying what's in the bracket, we have 4 times 3 is going to give me 12, 4 is going to give me 16, 4 times minus 3 is going to give me minus 12, 4 times minus 12 is going to give me minus 16. Okay, then minus, now 3 times 2 is going to give me 6, 3 times 3 is going to give me 9, 3 times 4 is going to give me 12, now 3 times 5 is going to give me what? 15. Okay, so at the end, let me simplify what is in here. Now here 12 minus 6 is going to give me what? It's going to give me 6. And then 16 minus 9 is going to give me 7. And then minus 12 is going to give me minus 24. And then minus 16 minus 15 is going to give me what? Minus what? 31. Okay, so let me remove this bracket because now it's going to be just a single bracket. So now let me expand this. Now 3 times 6 is going to give me 18. 3 times 7 is going to give me 21. Now 3 times negative 24 is going to give me 60 plus, so that's 72. That's going to give me 72, and then 31 times 3 is going to give me 90, sorry. 3 times negative 31 is going to give me negative 93, right? Okay, so let's look at another one. Let's look at how to multiply matrix. As I said, let's look at multiplication of matrix. Then we'll bring this episode to an end. Then we'll look at the next time. We'll look at the other ones, right? So allow me to clean this particular side. Let's look at the next one. Multiplication of a matrix by a vector. Okay, so if I have M equals A, B, C, and D, and I have V equals X and Y, right? This is in a vector form, right? Which we also call a column what? Matrix, right? Now, if you have something like this to multiply, the right approach is M multiplying V, right? That's going to be A, B, C, and D multiplying what? X and Y. Now, it is not V multiplying M. V multiplying M is not possible. There's no way you can do that, right? So it is not rather X, Y multiplying A, B, C, and D. No, this is not possible. So take note of it. Whenever you have a vector or a column matrix and it's multiplying a 2 by 2 or a 3 by 3 or any matrix at all, 3 by 2 matrix or any matrix at all, what you have to do is to first bring the matrix and then you bring the vector. That is the only possible way you can multiply them. Now in multiplying this one, look at the approach, how it goes. The first one, you take the rule of the first one, then use it to multiply the column. Then you take the rule of the second one and use it to multiply the same column, right? And in doing that, is this times this plus this times that. First one times first one plus second one times second one. So this is going to be, multiplying, this is going to be A times X plus B times Y. Okay, A times, so when you take the row, the first one of the row times the first one of the column plus the second one of the row times the second one of the column, right? Then we come down, since this is up, we bring it up, and then we come down. When we come down, C times X is going to give me, so C times X, then plus D times what? Y. So at the end, this is going to give me what? AX plus BY, and then CX plus what? DY. Are you okay? Right. So a typical example, if I give you 2, 4, 3, 3, and you are using it to multiply 2, 1, what happens is that, look, this times this, taking this first row, multiplying the column, the second row also multiplying that same column. So first times first, 2, 2, that will be what? 4, plus 4 times 1, second times second, that will be what? 4. Then you come down. Now 3 times 2, that will be 6, plus 3 times 1, that will be 3. So the final answer is going to be what? 4 plus 4 is going to give me 8, and then 6 plus 3 is going to give me 9. So whenever you multiply a matrix and a vector, the resulting answer becomes what? A vector. Okay? The resulting answer becomes a vector. Alright. Now let's look at multiplication of 2 by 2 matrix, and then we'll solve one example of that. Then you'll be given more questions to try. Let me clean this side of the board. So let's look at multiplication of 2 by 2 matrix. So supposing I have a matrix, if I have M equals A, B, C, and D, and if I have N equals X, Y, W, Z, then if I tell you to find Mn, usually this is where students find it a bit difficult. If I tell you to find Mn or M dot n, it means you are finding M multiplying n. This one means you are multiplying the coordinate of M by the coordinate of what? N. And this is very interesting. Look at what happens. The same thing we did here. We take this rule, it multiplies the first column and the second column, because we take this one as a different vector and this one as a different vector, okay? And then we take the down one too, it does the same thing, it multiplies the first column and the second column. With the same procedure that we used here. So look at what's going to happen. So we take A, so this times this row times this row, so A times X, right? So we have A times X plus this one will be what? B plus W. So sorry, times W. So A times X plus B times W, as we did it in the vector column. But the same thing happens here. So this time A times Y, since this one is at this side, we'll bring it here. And then plus second times second, so B times what? Z. Then we take the down column too, so C times X, right? Plus D times W. Okay, and then I have C times Y plus D times Z. Okay, so of course this is going to give me AX plus BW, and then this is going to give me AY plus BZ. This is going to give me CX plus DW, and then this is going to give me CY plus DZ. Are you okay? Right? So for instance, example, if I have M equals 3, 4, 2, 1, and if I have N equals 4, 3, minus 1, 2, then if I tell you to find Mn, this one means the coordinate of M, 3, 2, 4, 1, times the coordinate of N, that is 4, 3, 1, 2. So this is what's going to happen, right? I take the first row and use it to multiply the first column and the second column. So this is what's going to happen. So I have 3 times 4, that's going to be what? 12, plus 2 times 1, that's going to be 2, right? Then I have 3 times 3, that's going to be 9, plus the second times second, 4. 2 times 2 is 4. Then I come down here. So 4 times 4 is going to give me 16, right? And then plus 1 times negative 1 is going to give me plus negative 1 will give me negative 1. And then 4 times 3 is going to give me 12. And then 1 times 2 is going to give me 2. So at the end, the final answer is going to be, now 12 plus 2 is going to give me what? 14, right? And then 9 plus 4 is going to give me 13. Now 16 minus 1 is going to give me 15. And then 12 plus 2 is going to give me 14. So whenever you multiply 2 by 2 matrix, the resulting answer is going to be what? You still get a 2 by 2 matrix. Okay, let's do a last question. Let's try a last question and then we'll move on. Now this one I found mn. Now let me find nm and let me see. Now nm means this time n is going to come first, 4 3 next 1 2, and then m is going to come second, 2 4 4 1. Let's see. Some people think we are going to get the same answer. Let's see if we get the same answer, right? So this one, as I said, first row multiplies first column, second column, right? So 4 times 3 is going to give me what? 12. And then plus 3 times 4 is going to give me what? Another 12, right? Then I move to the second one. 4 times 2 is going to give me 8. And then plus 3 times 1 is going to give me 3. And then second one down there, negative 1 times 3 is going to give me negative 3. And then plus 2 times 4 is going to give me 8. And then negative 1 times 2 is going to give me negative 2. And then plus 2 times 1 is going to give me 2. So at the end, I'm going to get now 12 plus 12 is going to give me 24. 8 plus 3 is going to give me 11. Now minus 3 plus 8 is going to give me 5. And then minus 2 plus 2 is going to give me 0. Right? And please, this one doesn't mean 24 over 5. It's just 24 5. So it's 24 11 5 0. It's not 24 over 5. Some people like doing it that way. Okay? Alright, so I believe you understand up to this point, and we'll give you more questions to try. So on our next episode, we are going to look at determinant and inverse of a matrix. So until we meet the next one, thank you very much.